Ever wonder how that big, cold box in your kitchen keeps your food from spoiling? It's not magic, it's science. And today, we're going to break down exactly how a refrigerator works in a way that's super easy to understand. So, grab a cold drink from your fridge and let's dive into the cool science behind it. At its heart, a refrigerator is just a heat mover. It doesn't create cold, it just moves heat from the inside of the fridge to the outside. Think of it like a bouncer at a club, but for heat. The bouncer's job is to kick the troublemakers, in this case, heat out, to keep the inside cool and orderly. The whole process relies on a special substance called a refrigerant. This is a liquid that can turn into a gas at a very low temperature. In the old days, they used some pretty nasty stuff, but modern refrigerants are much safer for the environment. This refrigerant flows through a closed loop of pipes. Going on a journey that makes your food cold, this journey has four main stops: the compressor, the condenser coils, the expansion valve, and the evaporator coils. Let's follow the refrigerant as it makes its rounds. Our journey begins at the compressor. This is the heart of the refrigerator, usually a black, dome-shaped motor at the back. Its job is to squeeze the refrigerant, which is in a gaseous state at this point. When you squeeze a gas, its pressure and temperature shoot way up, so now we have a hot, high-pressure refrigerant gas. You can often hear the compressor kicking on and off. That's the sound of your fridge working its magic. Next, this hot gas travels to the condenser coils. These are the large, winding coils on the back of your fridge, or sometimes underneath it. As the hot gas flows through these coils, it releases its heat into the surrounding air in your kitchen. This is why the back of your fridge feels warm. As the gas cools down, it changes its state, or condenses, back into a liquid. So, what leaves the condenser is a warm, high-pressure liquid. Now for a bit of a dramatic change. This high-pressure liquid refrigerant flows towards a tiny little opening called the expansion valve. Think of it like the nozzle on a spray can. When the liquid is forced through this tiny hole, its pressure drops dramatically. And when the pressure of a liquid drops suddenly, it starts to evaporate and gets extremely cold. This is a key principle called the Joule-Thomson effect. It's the same reason a can of compressed air feels icy cold when you spray it. This super cold, low-pressure mixture of liquid and gas now enters the final stage of its journey, the evaporator coils. These are the coils inside the freezer or refrigerator compartment. As this chilly refrigerant flows through them, it absorbs heat from the air inside the fridge. Remember, heat naturally flows from a warmer area to a colder area. The inside of your fridge is much warmer than the super cold refrigerant, so the heat gets sucked out of the food and air and into the coils. As the refrigerant absorbs all this heat, it completely evaporates back into a gas. This gas, now carrying the heat it removed from inside your fridge, flows back to where we started, the compressor. The compressor squeezes it again, making it hot, and the whole cycle repeats over and over, continuously moving heat from the inside to the outside. So what tells the fridge when to run this cycle? That's the job of the thermostat. You set a desired temperature, say 4 degrees Celsius. The thermostat is like a temperature detective. It constantly measures the temperature inside the fridge. When it gets too warm, it signals the compressor to turn on and start the cooling cycle. Once the inside reaches the set temperature, the thermostat tells the compressor to take a break, saving energy. This is why you hear your fridge humming on and off throughout the day. And what about the freezer? Most refrigerators have a freezer compartment that gets even colder. This is usually where the evaporator coils are located. A small fan then blows the cold air from around these coils into the main refrigerator compartment. You can control how much cold air goes into the fridge section with a little damper or vent, which is why your fridge and freezer can be at different temperatures. Let's quickly recap the 4 main steps. 1. The compressor squeezes the refrigerant gas, making it hot and high pressure. 2. The condenser coils on the outside release this heat, turning the gas into a liquid. 3. The expansion valve causes a sudden pressure drop, making the liquid refrigerant super cold. 4. The evaporator coils inside absorb heat from your food, turning the cold liquid back into a gas, which then returns to the compressor to start all over again. It is a simple but brilliant cycle of physics that has been keeping our food fresh for over a century. From compressing a gas to make it hot, to expanding a liquid to make it cold, every step is a clever application of thermodynamics. The constant circulation of the refrigerant acts like a conveyor belt for heat, picking it up from your leftovers and dropping it off in your kitchen. So the next time you open your fridge for a midnight snack, take a moment to appreciate the incredible engineering at work. It's a silent, tireless heat-pumping machine, all designed to keep that slice of pizza or carton of milk perfectly chilled. It's not just a box, it's a beautifully simple system of pressure and temperature changes. I hope this demystified the magic of your refrigerator. If you found this explanation cool, pun intended, make sure to hit that like button and subscribe for more videos where we break down the science of everyday things. Got a question or another appliance you're curious about? Let me know in the comments below. Thanks for watching, and we'll see you in the next one.